So what we're going to do here is learn how to draw the chair cyclohexane. And as we do this, what I want you to remember as you draw an accurate chair is that every chair has 3 sets of parallel bonds. And if we take our model so we can actually see where those bonds are at, this bond and this bond, those are parallel. This bond and this bond, those are parallel. And then finally, this bond and this bond, those are parallel. So if you're going to draw the chair and you don't have a structure like this to draw on top of, the way I recommend starting is as if you were drawing a propane. Draw that. Now on one side, draw a straight diagonal line for a bond. Then move to the other side and draw a parallel line to that. Now finally we just have 2 more bonds to connect, and we need to draw one here that's parallel with this, one here that's parallel with this. So there's one, there's the second. So again, we have our 3 sets of parallel bonds. These 2 are parallel. These 2 are parallel. And these 2 are parallel. The second thing is the notion of upward pointed carbons and downward pointed carbons. And this is going to be useful as we start to draw in substituents. If the carbon of the ring is pointed upward, then we call that an up carbon. So the up carbons will be here, here, and here, because if you look at the bonds that make up that carbon, they're pointed up toward the top of the page. The other 3 carbons, where the bonds are pointed down toward the bottom of the page, those we call down carbons. So there's a down carbon, there's a down carbon, and there's a down carbon. So before we move on, take some time practicing drawing chair cyclohexane and make sure you can draw a correct chair with all of the bonds in the correct orientations with 3 sets of parallel bonds. What we're going to work on next is adding in the substituents. And in this case, it's all hydrogen. So this cyclohexane has 12 hydrogen. 6 of them are axial. The other 6 are equatorial. We're going to learn how to draw these in just a bit, but to preview this for you, the axial hydrogens are the ones pointed straight up or straight down. The equatorial hydrogens are the ones that are pointed out kind of to the side. We're going to start by learning to draw in the axial substituents. As we do this, remember axial substituents point straight up or straight down. We're going to do this in relationship to the carbon that they're on. So if we identify our up carbons first, we have up carbons here, here, and here. When we draw in the axial hydrogens, those should go straight up. So I draw a bond straight up, put the hydrogen in. Draw a bond straight up, put the hydrogen in. Draw a bond straight up, and put the hydrogen in. Now, when we do the down carbons, those contain the down axials, but those should be a straight line pointing down. There's that hydrogen, and then when I draw in this hydrogen, when I get to that bond, I'm going to leave just a little space here, and then draw the hydrogen in, And what this space does is represents that this black bond of the ring is in front of this red bond to the axial hydrogen. And then I need an axial hydrogen on this carbon. So now I have in all of the axial substituents. Now we're going to draw in our equatorial substituents. And equatorials point kind of to the side, but they must be parallel with a bond in the ring. And as we draw these in, I think you'll see what I mean. The other difference in equatorials and axials point in the same direction as their carbon. Equatorials point in the opposite direction. So on the up carbons, the equatorials will be down. On the down carbons, the equatorials will be up. So let's start in this top right corner, and I'm going to draw in the equatorial hydrogen, and it's going to be pointed net downward, but I need it parallel not with either of the bonds that it's directly connected to, but to the next bond over. So that would be these two bonds here. So now when I draw this hydrogen in, it's parallel to these two bonds. Let's do this one on the top left. Draw it in. And this one here, draw it in. Now on my down carbons, I'm going to have the equatorials that point upward. So here I have an equatorial pointed in that direction. Here I have one pointed there. And the bottom left, there. So now double check and make sure these are parallel with the next bonds over in the ring. Okay, so if we start with this bond here, it's going to be parallel to these bonds in the ring. This equatorial is also parallel to that one. Next, let's look at this bond. It's parallel to this bond of the ring and this bond of the ring. It's also parallel to this hydrogen. And then finally, we have this equatorial hydrogen. It's parallel to this bond in the ring and this bond in the ring. This equatorial hydrogen is also parallel to those. So when you're drawing the chair, having things parallel is very, very important. Okay, so here's our two representations that we've drawn so far. We have a representation with the hydrogen's axial, a representation with the hydrogen's equatorial. Let's add this up and draw a complete chair. So I'll draw in the first two bonds. I'll draw the two side bonds. Connect them together. So now we have our chair structure. And I'm going to draw the axials in red and the equatorials in blue just to help us differentiate them in this first drawing. So remember, if the carbon's an up carbon, draw your axial hydrogen straight up. If the carbon's a down carbon, draw the axial hydrogen straight down. On this one, there's two ways people will sometimes draw it. They might just draw it kind of short and put the hydrogen here, which is totally fine. A lot of times I will just kind of extend it and leave that gap to show that it's in behind and draw the hydrogen there. Either way, it's correct. So now we have our axials in. Let's now draw our equatorials. Here's one equatorial hydrogen. Here's a second. Then on the other side of the ring, got the third. And let me fix this. I don't like that because I want it to kind of be behind that red hydrogen because it's further away. So if you want to do that, remember you can just leave that gap to show that it's in behind. There's the fourth, fifth, and still I'm not happy with this because remember it should be parallel with these bonds in the ring. So let's back up. Try again. That looks better. Same thing up here. Now we're in good shape. We have our correctly drawn chair with all 12 hydrogen attached.